All right, ladies and gentlemen, we are getting into stoichiometry. Like I've been saying in class, this is one of the hardest topics that we have in chemistry, um, mostly because students don't follow directions and forget basic stuff like G stands for go to your periodic table and get your molar mass. Okay, so let's get started. Stoichiometry. Okay, stoichio is Greek for element, and metry, it means measurement. So we're basically measuring the elements. So write this definition down for stoichiometry. Stoichiometry is about measuring the amounts of elements and compounds involved in the reaction. So you're going to write this down, okay? Oops, right there. There's your definition, okay? Um, so we're going to consider the chemical equation. So here's one of our chemical equations. 4NH3 plus 5O2 yields 6H2O plus 4 NOs. Okay, so what does this mean to us? There are several numbers involved. Remember, we have the coefficients and we have subscripts. Okay, and remember we are and even though there's one here. So 4 times 1 is 4, and 3 times 4 is 12, and so on. So what do they all mean to us? Okay, so here's what they mean. Sorry, I'm getting a phone call. Hold on, guys. All right, so we're back. Sorry about that. I had a thing going on. Okay, recall that chemical formulas represent numbers of atoms, so that's why we learned how to count atoms. You have NH3, you have 1 nitrogen and 3 hydrogens. Okay, so that's just kind of review. All right, if you remember that we also have the formulas have molar masses. So if you break the N and the H3 apart, you end up with 17 grams per mole. That is your molar mass. Oxygen, O2, is 32 grams per mole. H2O is 18 grams per mole, and NO would be 30 grams per mole. Again, we are going to go to 2 decimal places. This one did not. So to find the molar mass, remember you got to multiply across and add down. Okay, why is this important to us? Well, because if you have 4 nitrogens, if you have 4 NH3s, you're going to have to go 4 times 1, which is 4 nitrogens, and 12. So you have to balance the chemical equations with coefficients. So it's important that we have a balanced chemical equation in there. So I'm not sure if it's on the next slide. I think it is, but balancing equations is key, okay? That's why we're spending so much time on balancing equations. All right, so with stoichiometry, let me back up. I think I did something. Okay, so with stoichiometry, if we have this, and I would write this one down right here. If we have this equation right here, with stoichiometry, find out that 4 to 5 to 6 to 4 do more than just multiply atoms to us, okay? So they are called a mole ratio. And I would definitely know what a mole ratio is because I'm going to tell you it's on the test. I put it there. Okay. So it can either mean if you have a ratio. Okay, let's back it up a little bit. If you have a ratio anyway, like let's say you have a 2 to 1 ratio, it means that you have to have 2 of these to 1 of these to make this work, right? Well, that's what's happening in stoichiometry also. So there's 2 ways you can look at it. You can have 4 molecules of NH3 react with 5 molecules of OH2 to yield, and I'm going to change that to yield, 6 molecules of water and 4 molecules of nitrogen monoxide. Okay, so that means that if I put 4 molecules of ammonia into a beaker, and I put oxygen in the beaker, 5 molecules of oxygen in the beaker, I'm going to produce 6 molecules of water and 4 molecules of nitrogen monoxide. Okay, other way to look at this, and I would be writing all of this down, you could say that you have 4 moles, and this is the one we use the most, 4 moles of NH3 to react with 5 moles of oxygen. When I put this ratio together, I'm going to get 6 moles of water and 4 moles of NO. Okay? So, all right. So how many molecules? So this is how this works. So we can go from mole to mole. Okay, because basically what stoichiometry is doing is we're trying to find out how much we are going to either produce, how much we're going to use, how many grams are going to use up, whatnot. Okay, so it says how many moles of H2 are produced if 2 moles of O2 are used. So again, just like we did before, you're going to circle what's given. Okay, and you are going to underline. Oh, sorry, I did this one too. You're going to underline what you're going to go to. Okay, so here is where we get our railroad tracks again. So you put 2 moles of O2. What's on top goes on the bottom. Moles of O2. Okay, you notice that we have to have this here. 1 goes here. All right, now we're not going to put a 1 here like we did when we were converting, because we're not converting. We're going to actually use a mole ratio. So what we're going to say is we're going to go how many moles of water. So moles of H2O. And ignore this little line up here. It does that sometimes. Okay, so what's our mole ratio for this? Well, I'm going to look right here. 6 is water and 5 is oxygen. So what I do is I put 6 and 5, okay? And what I do is I'm going to multiply across and divide for the bottom. So what it looks like in our calculator is 2 times 6 divided by 5. What's going to happen is the moles are going to cancel out of oxygen. The 1 is going to cancel out, and we're going to be left with moles of water. So 2 times 6 is 12. Okay, 2 times 6 is 12. Divided by 5 gives you, let me see what I got here, 2.4 moles of water. Okay, so it's going to equal 2.4 moles of water. This is why I told you to make sure that when you do this, you have your units and your substances. Okay, I'm going to stop this video for now, and I'll come back to it in the next one.